All right, hi everyone. So my name is Xiaowen Shin, and with me is Matt Silverlock. And we're really excited to be here today to talk about migrating and modernizing your enterprise workloads with Migrate for Anthos. So I think Migrate for Anthos is a really unique tool on the market, and it can transform your entire modernization strategy. But I'm getting ahead of myself. So before we talk about the what, let's first talk about why. Why do you want to modernize your workload? And why do you want to run them on GKE and Anthos? So there are a lot of reasons why you might want to run your workloads on GKE and Anthos. First, GKE and Anthos are built upon Kubernetes. So you've heard a lot about Kubernetes today. A lot of our customers who use Kubernetes are telling us that they're seeing a 10x improvement in the speed with which they can deploy and provision their workloads. In addition, our customers are seeing much higher utilization, leading to large double-digit infrastructure savings. And GKE built upon this and provides an easy-to-use, simplified management experience with features such as node auto-repair, auto-upgrade, and auto-scale-out. And Anthos takes that even further and provides an application modernization platform with a single pane of glass for managing all of your workloads, whether they're on-prem, on GCP, or on other clouds. And of course, when you run your workloads on GKE and Anthos, you get access to the best of GCP security with features such as binary authorization and container analysis. And so all of these benefits taken together gives our customers the ability to move faster, be more agile, and be more competitive in the marketplace. And so we see a lot of customers want to modernize, but it's not easy. And large enterprises have a lot of unique challenges. We have a lot of customers that have hundreds of applications. In many cases, they have thousands of applications. They were written over the last 10, 15 years, using legacy frameworks, running on legacy operating systems. So what do you do with these? It's not really practical to rewrite all of them, make them more cloud native, use a microservices architecture. So what do you do? Now the good news here is you don't actually have to rewrite all of them. We see modernization not as a binary problem. It's not all or nothing. And in fact, even though your application is not using a microservices architecture, you can still convert them to using containers and get a lot of the same benefits. So this is where Migrate for Anthos comes in. So Migrate for Anthos is a tool that helps you extract your legacy workloads from your VMs and automatically containerize them and run them on GKE. The tool is fast, it's easy to use, and it does not require rewriting your app. And that's a really key point. And so when you're done, you have your workloads running in containers, and you can leave the management of the infrastructure, of the underlying infrastructure, to us. And in fact, this reminds me of a conversation I had with a partner recently who was really excited about these features. He told me that VM management is actually quite error-prone and a big burden for IT. So if you are manually patching, manually upgrading these VMs, then after a few months of doing this over your fleet of VMs, you'll often see a few VMs that have errors, that run into errors. And what that means is it also affects the applications that are running on top of it. And so after he learned about Kubernetes, or learned about containers, he never wanted to go back to VM management ever again. And so VM management is, the elimination of OS and VM management is, of course, only one of the many benefits. A customer of ours, Dev Factory, recently used Migrate for Anthos, and they shared their experience with us. So previously, Dev Factory was using, they had a lot of VMs and servers running in a data center. And they were seeing less than 1% utilization. So these VMs were running there, they're costing money, but they're not really being fully used. So Dev Factory decided to use Migrate for Anthos to move those workloads to GKE. And immediately, they were able to achieve much higher resource utilization, leading to dramatically reduced costs. And also, they can leave the management of the infrastructure to us so they can reduce their IT burden. The overall solution helps them optimize their operations so that they can focus on their core business. Well, okay, so let's now dive a little bit deeper into the solution and see how it works. At a high level, there are 3 main steps. The first step is to identify good fit workloads. So we'll talk about what good fit means in a couple of slides. Your source VMs can be on-prem, on GCP, on other clouds, and it can be on physical servers. The operating system can be any one of the major Linux distributions. The next step is to migrate, using Migrate for Anthos. The entire migration can be orchestrated directly from GKE, will automatically containerize your VM workloads, and will move all of your entire workload, including your code, your data, and your state. So everything moves over to a container. And finally, the last step is to operate and optimize. So here you want to make sure that you've set up your networking rules, your firewall rules, access control, quota and alerting, and so on. And then you can enjoy the benefits of a managed infrastructure, including increased utilization, elimination of OS management, integrated logging and monitoring, and of course, the entire stack is supported and managed by Google. Let's now dive into that second step, that migrate step, a little bit more to see how we're transforming your workload. So if you take your original VM, there are a lot of things that are inside there. You have your application. It has attached storage. You're doing your own networking inside there. You have your DHCP configuration, for example. You have operating system services like SSHD, NTPD, and so on. The VM is managing the lifecycle of your application. It does its own logging, and you have your own OS kernel drivers all within that VM. So when we perform that transformation, we put that into what we call a system container. And you can see at this point, a lot of the components in your original VM have now been replaced and are now managed by Kubernetes. So your storage is now provided by persistent volumes within Kubernetes. Networking is now also managed by Kubernetes, so you don't need your own DHCP configuration, and it can seamlessly integrate with services like Istio. Operating system services like SSHD, some of those stay and some of those get removed, and that is configurable by the user. The application lifecycle stays within the system container. As far as logging, that's now integrated with Kubernetes and the cluster. And so depending on your cluster configuration, you can have all of your logs be sent directly to Stackdriver. And finally, your operating system kernel and drivers, those are no longer managed within your workload. So this is what we do today. Now, on our roadmap, moving forward, we have plans to break this up even further. So we will split your system container into one or more application containers, where each application and container can now be managed independently and directly by Kubernetes. So the lifecycle management of that app container will be managed directly by Kubernetes. Kubernetes will be able to independently scale the app up and down, independently manage the health monitoring for that app, and so on. And so as you can see, as we go through the phases, more and more of the infrastructure bits that was inside your VM are now taken out, unbundled from your workload, and can be managed independently and centrally within the infrastructure within Kubernetes. Okay, so zooming back out, a question that we get a lot from our customers is, what is a good fit workload? What are sweet spot workloads? So our solution is actually very generic. And so we work very well. It works very well for a lot of workloads. So common workloads with an enterprise like multi-stack multi-tier LAMP stacks or Java apps, those are really good fits. If you have low duty cycle and bursty workloads, those also work really well, because once you put them into a container, then it's easy to oversubscribe them, and you can very quickly scale up and scale down. So what's not a good candidate workload? All right, so you want to make sure that the workload will run well within Kubernetes. And so that means if you have high performance or high memory databases, that may not be a good fit. If you have special kernel or hardware needs, like if you need a special kernel module, that also may not run within Kubernetes. And finally, you want to make sure that your licenses, your software licenses, allow you to run within containers. So if you have licenses that are tied to hardware ID registration, that also may not be a good fit. And in some of these cases, you may instead want to use Migrate for Compute Engine to move your VM from your original cloud, original source data center into GCP. Okay, so another common question we get from customers is, once I've migrated my VM, my workload, into the cloud, how do I make sure that it's well connected? How do I make sure it's connected to my services that I need from on-prem? How do I make sure on-prem can talk to it? And also, what if I have some workloads that I can't yet migrate to the cloud? So how do I make sure that those are, everything can still talk to each other? So to tell us more about that, I'd like to turn it over to Matt. Thank you.
Thank you. So what I sort of want to talk about is sort of a couple of sort of customer examples where they've had these monolithic applications, and in these cases actually sort of before Anthos, Migrate for Anthos came along, so that would have saved them a fair bit of effort. But they've got these monoliths, they start on-prem, or even on another cloud, but we'll say on-prem, and they want to bring them across. And they want to start modernizing these applications, they want to break them down, they want to actually help them scale, right? But that's actually really hard. It's hard to start breaking these things up, and you want to do it in a really, really low-risk way, right? These are running, it's your e-commerce platform with billing integrated, with card integrated, with the web sort of front end all integrated. Just ripping them out ad hoc and rebuilding them is not normally sort of something that people want to do because it's still core to their business. So, we look at first containerizing the application. I think that's probably one of the most important first steps. That is obviously a big challenge for some legacy applications, but we have stuff like obviously Migrate that helps make that easier, particularly for Linux apps. And then the next part is like building a network foundation. So you want a foundation where you can start to break this app apart, comfortably route traffic and users to the broken out sort of services, and still make sure that the stuff in the monolith can still talk to those broken out services, that traffic can still go to that monolith when it's still handling certain tasks. In a way, again, that is like as low risk as possible, and that makes sure that you can potentially roll back or sort of manage around those changes, trace those changes, debug those kind of issues. And then once you have that foundation, you can start sort of breaking it down into microservices much more comfortably. Cool. So as a bit of sort of an overview of the major components, we've got containers themselves. We have a service mesh, which means a lot of different things to a lot of different people. But the idea is basically being able to have your services talk to each other in a controlled and debuggable way, and serverless. So that's the idea that you're not running sort of ops at a VM level or even in many ways a container level. Is you're just saying, look, I want 10 of these, I want to scale from 0 to 50. And when how this sort of fits into a whole toolkit, so you can see we have sort of Migrate for Anthos, and on the left we have Kubernetes itself, we have GKE on-prem. You have the spectrum of what we sort of think as the Anthos service mesh. So Envoy proxies, so if you've ever used sort of Nginx before, Envoy is sort of a superpowered Nginx with sort of dynamic configuration that you can sort of put as a sidecar or as a sort of a front proxy for your applications and do sort of traffic shaping. Istio as a control plane. A lot of things in Istio, so certificate management, acting as a control plane for your Envoy proxies via the Envoy APIs. Traffic Director, which is our version of the control plane as a managed service, since we know that managing control planes can be pretty hard. Layer 7 load balancer, sort of internal load balancer for managing traffic between services, built on Envoy. gRPC as a communication mechanism, and Cloud Run, which sort of goes back to the serverless part I just mentioned before. So these are all the components, and it's like, okay, great. How do I put all these together? How do I actually even know where to start? Right, I'm not going to boil the ocean and just do all of this at once. That just doesn't make a lot of sense. So again, we want to containerize first, and then we want to start to mesh our applications and build up the service mesh sort of iteratively and very slowly, so we can make measured changes as we go along. So sort of classic monolithic app. It's a big, probably existing Java code base, lots of different modules. Probably deploy it maybe once, maybe like 3 or 4 times a year if you're really lucky. But you want to actually be able to sort of break this down. You want teams to be able to be independent of each other to also avoid team A from blowing up the application of team B. So having canary sort of controls and things like that as well, being able to roll back. And that sits on-prem, and users come in directly, or maybe via some sort of DNS sort of traffic management system if you've got a couple of data centers. So very sort of simple, straightforward sort of setup with a lot of complexity underneath. And what we sort of want to think about is like, great, okay, let's start plugging in these pieces. So I have Google's network in front of my application, right? That's putting up our sort of global load balancer with Anycast, with DDoS protection, with sort of traffic routing, setting up an API gateway. So this is like the core foundation where, today that might be a really simple case of just forward everything to the monolith, but as you start thinking, you go, great, actually now I can start sort of carving up very easily and very carefully, my card, my payment system, my sort of billing backend, with this gateway ready so that when I start to break out this monolith, to break down this monolith, I have those controls there. And again, I'm going to say this a lot, you can roll back carefully and measure those changes really carefully. And obviously, what you start to do is you start to build that out and get your cluster ready on, say, GKE, which is going to be your foundation for starting to break these applications down. So you start to get some experience with GKE, you start to understand how it sort of abstracts virtual machines and sort of how it manages the network itself as well. Cool. So we're breaking out one service, breaking out, say, service A. That might be our billing service or maybe our cart service. At our API gateway, sort of that process is, hey, we're just going to send a small fraction of traffic over to that over time, and then as we're happy with that, that's going to take all of the load off the monolith, and our cart service is going to exist as a true microservice, and the cart team is super happy because now they're actually able to run things on their own. Again, that's a really sort of good developer experience as well. We are shrinking this monolith bit by bit, so now we have service B. That might just be our web front end, so that serves us all of our sort of user-facing pages. We've sort of brought that across now. Again, same process. Using our load balancing and the API gateway, we can make that a very sort of measured and sort of careful change. And now we're being able to rely on Kubernetes and GKE specifically to do auto-scaling of those services now that we've sort of broken them out, right? We can scale them independently of each other and independently of the monolith that they rely on or were relying on. Cool. We can get a little fancy. We can start to use gRPC, obviously reduce the overheads on sort of the traffic coming from our gateway back to our services, reduce latency in many cases, so we can start to sort of iteratively and carefully bring in these additional sort of modernization efforts as well as we break them all down. But hey, maybe there are some services we do want to keep on-prem. There are services, and as others have discussed before, regulatory reasons, maybe complexity reasons. Maybe there are just truly a lot of dependencies that are there. Maybe there's specific hardware requirements that we can't sort of get in the cloud maybe just today, or existing investments you want to sort of leverage. You're like, you know what? I'm going to break out service C, but I'm going to run it on-prem in GKE on-prem as part of Anthos. Keep that there. But hey, how does it talk to the other microservices, and how does it discover those things? So what we can start to build in is using sort of our Envoy proxies. This is the first step towards our service mesh. So in many ways, like if you haven't been familiar with sort of Envoy before, the way you normally set it up is in a container system, you set it as a sidecar. So all traffic coming into that sort of that container or those containers as pods in Kubernetes, it intercepts that is effectively a front, sort of a reverse and front proxy for all traffic coming into that application. You can do sort of canarying through that. You can have multiple versions set up. And you can do stuff like MTLS, so mutual TLS as well, and secure and authenticate traffic going between these services so that service B and C can talk to each other, but B should not talk to, say, A, if we had an Envoy there as well. Start to build this out a little bit more. So what we might have is we have a control plane. So that's the service mesh CP that you can see here. We need something to orchestrate our proxies, right? Maybe initially they had a fairly static config that we just built into a config map and we deployed it sort of, as needed. We didn't make a lot of changes, but we're realizing, hey, our operators need to be able to sort of roll this out again carefully. They want to be able to make changes dynamically without actually redeploying the application. That can obviously be very easy sometimes with Kubernetes, but if it's a very stateful application with a lot of dependencies, it's something you sort of want to take care of. And you might have a control plane on-prem as well for managing the envoys there. So you have these sort of two divorced control planes that do a lot of the same thing, and you can probably see where I'm sort of going with this. And what we sort of wanted to get to is what we call sort of traffic directors. So today, traffic director works through GCP directly, and we're building this out to sort of have a hybrid approach as well. So you can have a control plane on GCP managing all of your service mesh on Kubernetes. You can have it manage the service meshes in other clusters, be they on-prem, be they on other sort of cloud providers as well. That's really sort of the dream that we want to get to. So you have this like unified control plane that your developers interact with, and wherever those clusters are living, and I definitely recommend having definitely more than one cluster for blast radius. You can manage all those sort of as if they're one large unit and making sure that applications on, say, platform cluster A, doing, say, your like Jupyter Notebook management, something like that, or some data science jobs, can talk to the cluster running maybe some batch training jobs as well. So you want to sort of have that cross-cluster communication, but with a sort of centralized control plane as well. Cool. And this is the hybrid approach here. So having this sort of singular control plane, as much as possible, either abstracts the need to run a control plane on-prem, or controls the on-prem control plane so that, maybe in a worst-case scenario, if there was a connectivity issue between sort of on-prem and reaching out to the cloud, you have a local control plane that's going to continue to sort of operate for as long as it needs to on its own. Cool. So as a bit of a recap, you can see we've started off with this monolith, and we've started to break it down piece by piece. So we've taken this really carefully. We've built a load balancer and a gateway as a preparation and a foundation for how we want to do this. And that gives us, again, really useful capabilities for canarying traffic, for splitting traffic out. We're doing traffic on RPS and least connections, and sort of based on actually the load of my backends as well. I can obviously keep going down that path with my gateway. I've been able to implement gRPC to reduce overheads and increase the security on, say, connection to other services that support that as well. So as I've made those changes carefully, service A starts gRPC, I build gRPC into service B. I don't have to, again, boil the ocean, do it all at once. And then I've broken out the monolith sort of finally as a, we'll say service C here, but there could be services C, D, E, F on-prem. And I've had this sort of universal service mesh that sort of talks to all applications and manages the proxies, manages those sidecars for me as much as possible. Because again, what we are sort of getting to here is we don't want to be running all this infrastructure that's sort of like, in many cases, adjacent to the business goals we want to get to, right? Like most of you here have managed VMs, and now we have the cloud, which abstracts a lot of that, mostly. And we have Kubernetes, but Kubernetes has a large number of APIs, right? And if you want to start configuring, say, Envoy, go have a look at Envoy proxy, have a look at the config, have a look at how you sort of manage that, and you can imagine a fleet of those, you get this config drift. So control planes like Istio, control planes that sort of live like traffic director, sort of abstract the need to sort of have to do all this hands-on management, and you can keep everything a little bit more centralized, particularly from a security or ops team perspective. So takeaways, containerize first. Definitely recommend that. So that'd be, again, Migrate for Anthos as a great first start, and maybe if you have some Windows apps or things like that that can't sort of fit into that today, there's a process to maybe iteratively break that out yourself. De-risk your migrations by breaking them out piecemeal and having a plan for each sort of piece, right? Having a plan that involves the network so you can sort of make those changes quickly, again, roll back those changes and critically monitor error rates, trace where traffic's going, trace the performance of your sort of newly containerized and broken out applications, and leverage service meshes to bridge on-prem with the cloud. If you're going to be keeping your on-prem infrastructure or have a multi-cloud environment as well, you want to be leveraging service meshes to make sure that these things can communicate where they should communicate, where they don't communicate where they should. So you don't want like a PCI environment, for example, communicating with non-PCI environment. That's a horrible audit scope. Using a service mesh to prevent that at the networking layer can make that really easy, right? You can have firewall rules, you can have service mesh constraints, you can have MTLS constraints and layer those on to get that sort of multiple layers of protection.